Hello, everybody. Good morning, afternoon, good evening, wherever you are. Thank you for joining the next Cloud Security Masterclass session in our series. This one is going to feature Josh Stella taking us on a deep dive into the security of AWS Identity and Access Management Service. A little bit of housekeeping first. Want to let you know about our upcoming Cloud Security Masterclass. This one will be part 2 on building a highly secure Amazon S3 bucket. You can view part 1 available on demand. We also have a great conversation with Greg McCord, Global Head of Security at CalAmp. That was a really fun conversation. And stay tuned, we will be announcing another session coming up. This one is geared toward cloud engineering teams that need to bring their existing cloud environment into compliance, whichever compliance standard that might be. How to do that quickly with fewer headaches and less business disruption. It won't be focused on any specific compliance standard. It's kind of just sort of a tried and true process for getting that done as painlessly as possible. So next slide, please. Really quick, our agenda here is quite simple. I'm going to turn it over to Josh, and he's going to talk a little bit about why cloud security is different and why we need to think differently about ensuring the security of our cloud environment. Then he's going to go into a really deep dive into the security of AWS IAM. And then we'll get to your questions at the end, but want to emphasize that the chat is open to everybody. So we want this to be as interactive as possible. So please get any of your questions in at any point during this session. Josh is pretty good about checking the chat as he goes, but we've got Sivia here and I'm here to kind of help field questions as well. And AWS is a pretty complex topic. So if there's any kind of specific directions or lines of kind of exploration that you'd like to see, feel free to throw that out onto chat as well. So with that, let's get on with the show. Throw it over to Josh.
Thank you, Sivia. Thank you, Drew. And thanks everyone for attending. These are a lot of fun for us, and I hope they're informative for you. All right, a little bit about what we're going to do today and what we mean by a masterclass. So what we're trying to do is impart to you ways to think about these services and build them in secure ways on the topic. So we're going to do some technical deep dive into these security subjects. Some of our sessions, like the one with Greg McCord, was a conversation with a cloud security leader. Those are really cool too, because he has a different perspective. Mainly this third bullet is the one I really want to get across to you. This is about trying to help you reason about cloud security. And what I mean by that is, I'll use an analogy. You can see behind me some musical instruments. When you first start learning music, if you did band in elementary school, Mary Had a Little Lamb, you're playing by rote. You're playing by something where it is programmed what you're to do. And that is to develop your basic skills. Now, mastery comes in when you can start to actually think about the problem space and be creative and respond to the problem that's in front of you, the use case in front of you. So what I can't do in an hour or two, this is likely to be part 1 of 2, maybe more, on IAM. IAM is a vast subject. What we can't do is tell you everything about IAM in an hour. It's not possible. It's infeasible. And also, you won't really develop mastery of a topic until you become capable of thinking about the thing as a whole. So what I'm going to try to do today is get you thinking about IAM in a way where you can really own it yourself, instead of relying on examples, instead of relying on cookie cutter approaches from others. And finally, we like to have some fun. All right, and if you've done these with us before, you know what I'm going to do next, because we like to kick it off this way. Every so often during the presentation, I'm going to throw up a Zoom background of something from like the parts of geek culture that I love. It's computing, science fiction and anime, video games, and let us know in the chat if there's one of those topics you want to start with. But I'm going to start with history of computing here. And the way this works is the first person to put in the chat to identify my background. So if that's a computer, it's name the computer. If that's a scene from a image from a movie, it's name the movie or the anime. If it's a scene from a game, name the game. The first person that gets that, and if you've been to these, I do reuse some of them. You'll see some new ones, but don't be shy if you've seen them before. We try to pitch you some softballs every now and again. But the first person in the chat wins a swag pack. We know that everyone loves going to conferences and getting swag, and COVID has prevented us from doing that. So we're going to send you a really cool package of swag if you win. Now, if you win once in this session, you can't win again. So please don't spoil it for others. Once you've won, even if you know, keep to yourself, because you can't win twice in a session, and we don't want to give it away. Okay, let's start with something from the history of computing. All right, why is that not working? Come on, Zoom. Hold on, let me try this again. I think Zoom got oh, it's because I'm screen sharing. Give me 1 sec. All right. Let's do that again. I hope it's because I'm screen sharing, not. Okay, there we go. So I've got a background up. Oh, who was first?
It looks like Joe Goldberg.
No, Bill Mitchell. Bill Mitchell in with the immediate.
Bill.
Okay, yes, this is a Cray 1 supercomputer. Very famous and also very cool, liquid cooled, and it came with its own very stylish 1970s bench. So if you didn't, well, around the outside there on the bottom, if you didn't win, there will be more chances, but we're going to keep rolling on. So we try to keep it fun. We'll get my chat back open because every time I switch from screen sharing, I lose it. All right. So a little bit about cloud misconfiguration. All right. Cloud misconfiguration is having gaps that bad guys can exploit, that hackers can get into through the configuration of your cloud infrastructure. Misconfiguration is a very complex and difficult problem. And IAM, by the way, is one of the most difficult places to get it right. So I'm really excited about the topic today. This is from a survey we do every year, asking people who are kind of at scale on cloud, what their concerns are around security. So there's over 100 organizations operating at scale on cloud. 84% are concerned they've been hacked and don't know it. That is wise. If you are concerned about that, you should be. Everyone should be. A lot of these cloud breaches are undetectable, well, nearly undetectable, very difficult to detect, even after they've happened. And 92% are concerned they're vulnerable currently to a cloud breach. Also wise, these should all be 100, but I like stuff over 75%. It means people are thinking about the problem honestly, right? And that's a big part of addressing security, is not being, not having rose-colored glasses on, but actually understanding the risks, and they're profound. And then finally, misconfiguration will increase this year. 3/4 said yes, and that's also true. And we're going to get into some of why those things are in this session as it relates to IAM, which is just central to cloud security on AWS. So David Linthicum from InfoWorld sees a lot of cloud configuration errors in the real world, and it's scaring him. Yes, this is, by the way, I'm Josh. I'm the CTO and founder at Fugue with Drew, co-founder. Prior to that, I was at AWS, where I worked as a principal solutions architect for like DoD and national security kinds of concerns. I'm a software developer and architect for a long, long time now. That's where I came from. So for whatever credit that gives me, this is all I've been doing for almost a decade now. A little bit about how hackers get you, okay? In the old days, the kind of the Hollywood version of hacks, right? You identify the target. We're going after the people in the basement going after a particular target, and then looking for vulnerabilities. Now that still does happen. Sony Pictures really ticked off North Korea with a movie they made, and North Korea targeted them and did spear phishing attacks and phishing attacks and stole their data. It does happen. But much more often, even on high profile breaches, what the bad guys are doing is using automation to go identify vulnerabilities in your infrastructure, and then collecting those into shopping lists. So, you know, Acme Corporation has this particular vulnerability, and that shows up in a log somewhere, and they go and say, oh, well, I'm going to hit Acme Company. So what this means is that these skilled and well-funded hacker groups, they're using automation to discover and exploit misconfigured assets. This says from John Breeden, within hours of their deployment. That is far too optimistic. It's usually within minutes of deployment. So once you expose the system to air, the bad guys know if you've misconfigured it. You should just assume that. And you should assume that you do have misconfigurations. All right, we're going to drill in today. Yeah, Samuel says it's minutes for sure on the bad guys. Yes, it is. They are quick. All right, this session is going to be a little, I have no slides for this. I'm just going to speak to some topics, show you the AWS console and documentation, and we're going to do a little whiteboarding because I think one of the fundamental problems in addressing IAM is its perceived complexity. And when I say perceived complexity, it is very complicated in implementation, but conceptually is pretty simple. And I think breaking it down to where you can think of it in simple terms, given that you're going to be dealing with a lot of moving parts, but understanding how those parts relate is key to kind of grokking IAM. So what I'm talking about here is a mental model. And whenever you're designing software, you have to have a mental model that you can work with, right? In order to make decisions. And again, getting back to mastery, I can't tell you how to do your use case with IAM. We're going to cover a few use cases today and talk through them once we get a little bit of the foundation laid. But your use case is going to be unique to your organization. So what's really important is that you can reason about it and you have a mental model for performing that reasoning. And I'm here to tell you that the IAM and policy model in AWS is actually pretty simple. In implementation, there's all kinds of complication, lots of ways to do these operations, but the mental model is pretty clear. All right, we're going to walk through 3 use cases, mostly verbally. I'm not going to be building stuff today. It takes a little too long. We've only got an hour. But the 3 use cases we will cover by the end are 1, the most basic and fundamental one, which is how to set up an AWS account using IAM users and role-based access controls through groups for those users. Okay, that's the simple one. We'll drill into that. The second one is what happens when you go to a much larger scale of deployment, where you don't just have the RBAC model starts to fall apart, and I'll explain why that falls apart shortly, and you need more and better control. And so we're going to cover that, and that has a lot to do with what's called ABAC, attribute-based access controls. And then the third one we're going to talk about is one that people often kind of gloss over, but is actually the vector for a lot of data breaches on cloud, which is when you don't have users as the principal, you have compute resources as the principal that has access to other compute resources via IAM. Okay. So I'm going to do a quick walk through the AWS. Oh, come on, AWS logged me out right before I got on here. You know, log me in? Yes.
While you're getting back in, Samuel has a question. Before we dive, what is your view of inline policies?
Yeah, I'm not a huge fan. Inline policies, I mean, AWS tells you not to use them. Well, when AWS says you probably shouldn't do this, what they usually mean is please don't do this. I mean, they're not the end of the world, but what you end up, so one of the fundamental problems with IAM is you end up with policy proliferation and the ability to find all those policies. Sam he says, I am asking because AWS has a hard limit on the white space 6044 policy. So I believe what you're saying there is a limit to characters in policies and inline policies. That is true. But that's getting a little in the weeds to start. But yeah, so they don't want you to use inline policies. They're probably not going to be like helping you do that more, okay? Because they want you to associate policies via things like groups and roles. They just do. And there are good reasons for that around IAM policy management. You don't want too many IAM policies. And the reason I'm laughing is I have pulled up my own demonstration account. Right, this account is not set up to best practices. It's set up to bad practices, by the way, because I use it to just demonstrate how to get things wrong and break into stuff. But you can see here, I've gone into the IAM console and I've just selected policies. And even though I only have a couple of my own policies in here, so policies are how you define IAM access and authorization privileges, okay? Actually, yeah, authorization, not authentication. So, but you see here, I have 675 results. Why do I have 675 policies when this is a relatively empty account? Because almost all of these are automatically shoved into your account by Amazon to do very specific things, okay? We're gonna come back to this. Now, I want to switch from the reason I'm bringing this up is this problem of kind of volume of work, right? How many policies do I need? Whether they're IAM access policies, whether they are resource level policies, et cetera. And I'm going to show you that IAM, by the way, is just one type of policy, and that you really should think of AWS policies as a collection of stuff that determines what can happen. Well, the reason they have 675 of them is what has happened in the architecture of AWS is there are a proliferation, a very large number of what are called actions. And this leads to most of the intimidation factor of using IAM, and it's for a reason. Let's switch briefly to their documentation. Okay, so this is the understanding how IAM works. Personally, I don't find this diagram super helpful. So I'm gonna whiteboard a totally different way of thinking about this. This may be informationally accurate, but it's not the greatest mental model, and it doesn't really cut things down. But you can see here, this is how AWS describes it. You've got principals firing off requests that go through authorization, and then actions to resources. I'm going to draw this a different way. I'm going to switch to a whiteboard, and you're going to see my bad handwriting. So let's talk a little bit about what these things actually are. Okay, principals are things that do actions via IAM. All right, so let's just put a user here. We'll go over user guy. User, so human user. But then you can also have a process, right? You can have a cloud resource like an EC2 instance that has an IAM role. You can have IAM credentials that are being used by an application. Anywhere that you are using IAM as a way to grant access versus having like a TCP IP based access to a semi-public S3 bucket, that's a principle in AWS policy world, okay? And I mentioned IAM policies aren't like some special magical thing. They're just policies, and we're gonna talk more about policies and what they mean. Now, does anyone know what the default policy for every single thing in AWS is? Just throw it in the chat. There is a default policy. Yeah, deny, yes. The default policy is no. That is the correct way to go. So I'm just going to draw a line between principles and everything else. Let's see if I can, it's straight enough. Okay, so the next thing that I use in my mental model of how to deal with this problem space are actions. Now, this is where the train starts to roll down the hill pretty quick, okay, in terms of what you're going to have to deal with in terms of thinking through this space. All right, so what does AWS mean by actions? Let's take a look at just the EC2 actions. Okay, so what I want you to do when you're thinking about AWS policy and IAM is I want you to forget there are different cloud services. Just stop caring about that for the moment. It's just going to make you think about this in a way that's unhelpful. Devils live in details. Those things do matter in the long run. But to have a mental model, the way I want you to think about AWS is just a massive list of actions of all the services combined. Okay, so these are essentially API calls that can be made, right? That's what AWS means by actions. So just in EC2, and EC2 is kind of the pathologic example of growth in actions over time. We'll start scrolling through here. There's a lot of them, okay? That's EC2 alone. There are hundreds of services now. So the way I think about and encourage you to think about AWS policy first is whether a principal can touch a particular action. And for those of you who've been doing a lot of this might sound quite remedial, but I think it's really helpful in terms of how I think about these things to think through what's really going to happen, okay? So this is also where IAM, if we go create a new policy, we can select a service. Let's choose EC2. So I'm creating a new policy. Remember, the default action is deny. That means I have no access to anything. What I'm trying to do here is grant something, a user or someone else, access to some parts of EC2, okay? Now, you saw in the docs here, they have a bunch of like subsections in the docs, you know, AMIs and marketplace and bundle tasks. That's not available to you when you're programming against the APIs for wildcarding, okay? The only wildcards like list star are these list, read, write, read, tagging, write, and permissions management. And by the way, don't ever use wildcards. Don't ever use wildcards. And a lot of people are going to hate me for saying that, because I'll show you next why that is such a painful thing to say. And this is the kind of key complexity, or it's not even complex, it is complicated, by which I mean the fact that the design decision was you're going to assign permissions on a policy basis to every single one of these things, and then filter it down later, which is how this stuff works, which I'll show you in a minute, means you have to know which of these you need specifically. That is the main challenge in IAM, is understanding specifically which of these you need to perform a given function. The number one mistake doing IAM is to turn on star and start taking things out. It may sound really painful to do it the other way around. It is really painful to do it the other way around, but it is by far the safer way. But back to the kind of architectural mental model here. So now we've got these lists of actions, right? And there's a lot of these guys. I haven't counted, and I thought about 10 minutes before this, maybe I should have done, you know, a script to just count them all up. But I can tell you EC2 alone has, oh, come on, computer, around 400. Okay. Now, what an IAM policy is mostly for, as with most things in AWS, there are all kinds of additional edge cases and little kind of hacks and workarounds and so on. And I'm checking time here, we're halfway through. I'm not going to nearly get through everything, so I'm going to try to accelerate. what you're doing is you're poking holes in this deny everything, okay? You're poking holes with your IAM policy so that these actions can be accessed, so that you're not getting, and specifically the ones you need, and you're not going to be denied over here, okay? There is another component that you're going to really be thinking about when you're designing policies, especially in complex use cases, less often in IAM, but it's really important to understand this exists, are the resources, right? So let's say we've got an EC2 instance over here. That, and its name is foo. That resource has those 400 or so actions that the EC2 service type has on it. And so assuming you just have an IAM policy in play and no other layers of policy, what this means is if you have an IAM policy that lets you do, oh, I don't know, describe, come on, computer. And I don't know, we'll forget the other two. Describe call and a couple other calls from that list of 400. That means that this principle makes it through the policy evaluation and then it can access those things on EC2. But wait, there's more. Okay, there's more. I'm going to switch to stopping sharing and do another background because we're already halfway through. These things just fly. I never think I've prepared enough. And then I've always got way too much material. Let's switch to, anime. All right, I've got an anime up here in the background, and I'm going to look and see if we've got any questions in chat while we're doing, oh, man, oh, that happened so fast. Okay, DS was first on the stick there, Cowboy Bebop. All right, that was too easy. You guys are pipping these off right away. You're either repeats or you have similar taste to me, and whichever one it is, we gotta give you a harder one. All right, back to computing. Name this keyboard. It is a, DS, yeah, Sivia will reach out to you. Okay, name this keyboard. No, it is not. Dvorak. Oh, Bill Mitchell got it. Symbolics.
We're gonna let someone else guess. Bill's recused himself.
Oh,
So.
okay. Well, I just blurted it out. Okay, we got to switch it up. I'm going to give you another computing one.
And Joe Goldberg, if you look in chat, I sent you a private message, so you may want to respond if you're still on.
Bill says he had studied for that one. All right, this is a very famous computer, and a hint. You can see it has a circular screen, which is cool. And it had a light pen in like the early 60s. And it is the computer that the very first graphical video game was ever written on. All right, I got to decide while we're waiting. Okay, well, I'm going to turn it back over to, here, I'm going to direct message Sivia and let her know what it is, just in case, so I can keep moving. It is not a Multics machine. Oh.
Bill.
Bill's telling the panelists. He's not telling the attendees.
That's true.
That's fair. He's right, Sivia.
Yes, he is.
Okay, cool. I'm going to go back to sharing my screen. So where we left off, I had painted this simple picture. And by the way, I think for me, this is the only practical mental model I've come up with for dealing with policy in AWS. There are really only 3 things. There's 3.5 things, but I'll focus on the 3 right now. There are principles, things you're granting permissions to. There are actions. All of AWS is a massive stack of actions, and those actions map to the resource types that have those actions. Okay, that's it. And policy is just a bunch of filters. Okay, so we said default, you guys told me right away when I asked, you said default is deny, right? Yes, default is deny. However, when you open up permissions using IAM, you're now getting through. But if there are other kinds of policies also in this policy evaluation stack that denies something the IAM role said yes to, it gets denied, okay? So any denial in the evaluation of the policy stack will deny it. Now I want to talk a little bit very briefly about, what really is AWS. So when you build a VPC network, there is no network being built. When you create a Lambda function, there is no new compute being deployed. All of this stuff, those are kind of skeuomorphs, like even analogies for a big configuration of these actions and how they're configured, okay? So when you're thinking about this, just forget all that. A VPC network isn't a network. It's just a configuration made up of actions, okay? Same thing with EC2, same thing with everything else. So what other kinds of policies might there be? A bunch. And we're going to talk, is it this one? Yeah, here we go. Okay, so back to the AWS docs. We've got some policy types. So identity-based policies, which is really what I was talking about so far. Attach and manage inline policies to IAM identities. Okay, well, and resource-based policies. So these are the policies that grant stuff. They typically give you like allows. Okay, so if I go back here to, by which I mean, ways to get around the denies, right? The default deny. Let's take a look just for a second at one of these AWS managed policies, okay? And let's take a look at policy versions. So I really like looking at these policies, and actually this one's a little bit, I want to find a simpler one for you if you're not familiar with these. And I don't want a full access. Maybe Amazon Chime user management. Okay, yeah, we got 8 versions of that one. All right, if we take a look at this policy definition, you're not seeing in the action list, right? That's the actions. You're not seeing any stars. You're seeing an enumeration of all the things that are needed for this. And then it's saying on any resource of that type. And that's a really common pattern when working with IAM, because otherwise, if you start like having different IAM policies that point at different resources, you end up with a proliferation of policies, okay? And that's one of the bad things, because you get out of step on version, all kinds of things can happen. Now, one other point about why you don't want any star actions. They add actions, right? EC2 was not born with 400 actions. It wasn't even a tenth of that. So if you have a star in your policy and that service is accumulating new actions, you're inheriting all that accumulation without necessarily having any idea what they're potentially giving your IAM policies access to, okay? So lots of reasons not to use star. Do what AWS says here, imitate them, use the AWS managed policies as ways to learn about this, okay? All right, but let's go back to talking about policy types. So now you can get into some other stuff. Permission boundaries. All right, that policy defines the maximum permissions that the identity-based policies can grant to an entity, but it does not grant permissions. All right, so what we're doing there is we're starting to filter back out what the IAM identity policy granted. So going back to our diagram, so we've got all these allows, right? But what if we have some policies in here, because we don't want necessarily every user with that IAM role. Let's say this IAM role here is called developer. Well, some developers should have access to all those things, and maybe some teams shouldn't have access to all those things, right? But you don't want like developer V1, 2, 3, 4, 5, 6, 7, 8, 9, 47, 923. I see a lot of that. So you can use these other policies to put denies in. So maybe just this one can go through here, right? And so the way I want you to think about policy is you're giving and you're taking away. And there are lots of ways to do these things. Not so many ways to tell AWS what's allowed. There are a few. IAM is the primary one with these access policies. But there are lots of places you can say no, all right, further through that policy stack. So you cannot understand IAM without understanding these other kinds of policies that can then be used to kind of choke things back down or orient them in a different way. So permission boundaries, I can turn off certain access. Organization SCPs, right? A service control policy is kind of like a master deny list that an organization can push out to accounts. So even if you make an IAM policy that says I can do foobar and BAS, if the organizational SCP says, no, you can't, then you're going to hit a wall there. Now, I want to take a side for a minute here and talk about the two primary ways I've seen organizations get this wrong. Okay, the two ways, and they actually end up yielding almost the same result in many cases, are one, not getting their hands around managing IAM roles and letting them proliferate and letting everyone in the organization add roles, or even not everyone, but lots of people, and not keeping on top of it. That's a mistake, definitely. A lot of organizations say, hey, we don't want to be that organization. So instead what we'll do, they'll make the other mistake. They'll clamp down really, really, really hard. Okay, two things happen when you clamp down really hard. One is you create a ton of friction for developers to do their jobs. Okay, and that almost always happens where, you know, whether it's a new service type or it's a new action on a resource, if there's some big grinding old school process, manual process to go, you know, beg for permission to do something new, you've slowed down your organization on cloud. And what I've often seen happen is eventually that organization, that team in the organization said, we're going to clamp down IAM. Nobody's going to have access to any of this stuff. It's crazy for them to be able to touch it at all. They can come through us. Most of those teams eventually lose that authority. And the reason they lose that authority is because they end up being a bottleneck to progress, because this is hard to get right. Okay, so there's a sweet spot in the middle. Where that sweet spot is very much dependent on your organization, your way of working, your use cases, your exposure to risk and sensitivity to risk, whether you're regulated, et cetera. But there is no silver bullet here. You really have to understand it, and you really need the right amount of flexibility and the right amount of control. Okay, so the reason things like organization SCPs exist is for you to say, we absolutely don't want anyone to be able to, I don't know, maybe it is create an IAM role. Maybe it is, you know, delete S3 buckets. Like you're going to reserve that to just a central resource. Maybe it's change topology of VPCs. But I would argue that this list should be, generally speaking, not so long, because there's other things you can do that are better. Okay. ACLs are in here as policy. ACLs are largely a figment of what's the word I'm looking for? A result of the history of AWS. Kind of things like S3. ACLs were initially the only way you could restrict access to them before they got all kinds of new features. ACLs came out before IAM. I wouldn't worry about ACLs unless you're dealing with a whole lot of legacy stuff. Okay, and then session policies. You can have these temporary assume roles and federated user roles for a session. And so that's another way. But going back to our diagram, right? We've established you can create that policy, that IAM policy, and then you can also start to, let's just say this is an SCP. Now, let's put an S3 bucket over here. Let's say that this role here, this user, this policy over here, rather, is supposed to be able to do list commands on S3. All right. Personally, I think list commands on S3 are one of the more dangerous actions to allow, but a lot of people leave them on for convenience during development. So let's say in development, that's good, but in production, you don't want that. Very reasonable thing, okay? So you have a copy of this S3 bucket over in dev, and it's like, that's fine. We don't have any real user data in it. It's not exposed to the internet. It's on a closed VPC network. But once we get to production, you're not allowed to see, enumerate the contents of that, because that is a permission that if a bad guy got access to this IAM role, them being able to list S3 is super scary. So here comes another kind of policy that you have to be considering in your bag of tools, called a resource policy. So a resource policy can block stuff on that particular resource. So let's say this is BAS, the S3 bucket. So BAS, the S3 bucket, has a resource policy on it. And remember, we got to get allows through all the policies in that policy evaluation to do the action, right? So here, if this is S3 list buckets, and this policy says, yeah, go for that, no problem. I'm actually kind of successfully getting through the action, but what's going to happen is when that hits the deny on that particular S3 bucket, the one in production, I'm going to get a deny. And so for me, the mental model here is, what are your gates in terms of layers of policy for the resources and services that are important to your application? All right, I'm going to pause here for a sec and we'll do a background and see if we've got any questions. Feel free to fire questions into the chat as we go. All right, let's do a video game. You know what? Let's do an anime. Man. Okay, I gotta mix these up now because I see maybe some repeat attendees. I don't know. So NS nailed that right away. Samurai Champloo, absolutely awesome anime. I'm gonna do another one just because you're getting these so fast. Clearly, I need to up my game here. All right, let's do this one. Probably a little harder, less iconic. Akira Evangelion. Yep. Siri Oaklander. Siri Evangelion is the answer. One of my all-time favorite animes. Okay, back to some screen sharing here. Well, I promised you, I had some more kind of interstitial content here, but I do want to get to some simple use cases. Okay. So the first use case I said we would describe is kind of your basic 101 setting up an AWS account with IAM. So what do you get out of the box with an AWS account? You just get a root user. Don't ever use it. Use it to just get your account set up. Now, I'm not going to get into if you're using organizations and stuff like that. Just like totally simple to wrap your head around, how to address IAM in the most simple role-based access control sort of way. So you're going to get a root user that can do everything. Obviously, that is a bad idea to ever use. It's like root on Unix, right? Don't do that. You should never do that. You kind of lock that away. So what you're going to do with that root user, I would argue, the first thing you want to do is think about, because you're going to use that root user to set up some initial accounts, unless you're using some other services that complicate this description. So think about what your users' categories, the groups are going to be, right? Because we're talking about role-based access control. And in the case of users, we're talking about human users, human principals that are going to be acting against that cloud infrastructure environment. So some pretty normal ones would be like a group for developers, a group for the DevOps team who probably needs more access than, now you might be like us at Feud where there is no distinction. Everyone is both. We're like I came from AWS, it's the total ownership model and all that. But you might want some separation of concerns there. There are some great built-in policies in AWS, and I would argue using those where you can So let's see here. Where did I lose them? Back over. Here we go. So if you look at policies, you'll see stuff like security audit right here. You get that out of the box. So you might definitely consider using, and you can see this, if we go look at the policy versions, I suspect, yeah, it's on version 32, and I think this is going to be pretty long. Yep, fairly long. Excuse me, I need to take a sip of water. So you're going to go in here in groups and, you know, create some new groups. You know, developers. And then you're going to assign a policy to that group, and then you're going to put users in that group. And then you're going to stop using root. Okay? That's the most basic way to do this. And it's a good way to start. This gets back to things like inline policies. You don't want inline policies. You want that indirection. And the reason for that is now if you have a mapping from the user to the group to the policy, when you change that policy, it's inherited by all those principles, okay? So you can do it the other way, but don't. That's one reason AWS, I told you it's because of policy management. Imagine if you had policies embedded in all these different places, how hard it would be to get your hands around, okay? So that's like the really basic version. I want to talk about one other use case, actually two other use cases. The next use case is, okay, but what happens when I have 50 different teams? And the developers on one team should not be able to see the resources by another team. Ah, this is interesting. What's missing from my diagram here, right? What do I not have an easy way to represent? And that is collections of resources mapped to actions. But that's a very normal thing to want, right? If you have a bunch of different development teams, you want them to see their stuff, but not everyone else's stuff. Now, one thing people have done in the past is give every one of them an account. Well, that can make sense. I generally argue for more smaller AWS accounts, but it's very often true that you actually need to restrict on resources. Well, you could say, can't I put resource policies on those things? That's another nightmare, right? That's another nightmare. Because now you've got policy proliferation again. Like the hair on the back of your neck should stand up every time you're adding policies. You should say, wait, this is a liability that I have to manage forever. Do I really need to do this way? Because there's probably, and this is where I said this gets complicated, there are different ways to assert control other than proliferating policies, and those have grown over time. So there's another one that's kind of newer called attribute-based access control. And I want to point you there if you are doing lots of different development teams or just different teams, and they should have limited access based on something other than resource type and account, okay? And the way ABAC works, did I pull up the, I don't even know if I pulled up, let's just do a Google search. I had this at one point, but I lost it along the way. Okay, here we go. What is ABAC for AWS? So ABAC for AWS is a way where you can have another filter, right? Another policy that can do denials, and it's going to be based on tags you put on resources. So independent of whether, and the way to think about this is just another filter, right? So here's your resource policy over here, right? Well, ABAC can be thought of as just another filter. And what ABAC is going to check is, does this thing have tags on it that match the appropriate tags on this particular principle? And if not, I'm going to deny. Okay, so this is another way to do it. Now, the beauty of that is you are now not proliferating policies, you are tagging objects. Probably you are already tagging for things like which application, which team, etc. Okay? I'm gonna quick look over at chat.
Yeah.
So we just covered 2 use cases, and we're gonna do one more really quickly.
We do have one question here I can throw over to you. Are there any best practices that you have found for teams that need ever expanding access to production workloads? For instance, and I'm kind of paraphrasing here, modern teams that are running data applications such as machine learning or AI often need near admin or at least some resources. And are there any frameworks or anti-patterns regarding this?
Okay, that's a really good question. I put up a new background. It's a video game. Man, I feel like I've either used these up or you guys we're communicating very well on our geekery. Yes, Chris Isa, Near Automata. It was a really cool game from a few years back about machine consciousness and robots that fight. Yeah, so if you have, one, I would challenge the assertion that any team needs near admin and prod, okay? Personally, my kind of rule of thumb is in dev, I don't really care that much if there's not really customer data. I don't care. I want to give you as a developer as much liberty as I can. Now, one thing you can do is if you're a security-minded person or a cloud architect or something like this, and you're concerned with the developers going and needing near admin, you can say to them, hey, look, I want to give you everything you need for your app to work. What I need in exchange is for you to tell me which actions you need. I need an actual enumeration of those actions. Now, if you're writing a cloud-based application, there should be a way for you to know by looking at source code or libraries, or there are analysis tools in AWS that will tell you like which IAM roles are actually using what. I view all that stuff, by the way, the analyzers and all that, they don't really help you as much as just understanding how it works and putting in the time to architect correctly. So I challenge the assertion that any dev team needs near root privileges in prod, maybe in dev. Now, if you do in prod, and this might be getting to the third use case, which is around the principles, not inhuman principles. Oh boy, Near Automata is like perfect for this transition because those are AIs. But here we're talking about, processes, like an EC2 instance. I think of that as just being like a process. Well, it can be granted a policy through what's called a role association. This is the third use case, and this is the super, super scary one, is where you have IAM policies that are being used in your compute infrastructure, which is internet facing, that themselves are over permissioned. This is like 70% of breaches that we see out there. They're not like a AWS user credentials being stolen. That happens, but a lot of times it is getting purchase inside the infrastructure and then using an overly permissive IAM policy that's associated with an EC2 instance or something to go steal data or stand up new compute infrastructure for crypto mining, cryptocurrency mining, or what have you.
So there's one question here from Samuel. Is that true for dev, that dev is dev, but in many environments, dev is prod?
All right, if your dev is prod, and by which I mean, now, there's the quips out there about how like, if I'm gonna make changes to my application, I'm gonna do it in prod. Sometimes you have to, right? But if you're concerned with security and you're concerned with permission boundaries and things like that, and I promised to talk briefly to which one was it? Well, hold on, I'll come back to that. If you're concerned with not having all your data stolen, when it comes to IAM permissions and access and the policy stack and policy evaluation, don't make prod dev. Just don't do that. Now, you can do stuff like run our tool Fugue against it, and it'll tell you if you're, overly permissive or whatever, overly privileged in your IAM grants and so on. But you know, that's a little bit scary. So if you're, in other words, I would lose less sleep at night if we had a hot fix to put out. So we run a big, huge SaaS on AWS, mostly using like Lambda and those kinds of, oh, I see, I got you backwards. You're not saying prod is dev, you're saying dev are treated as prod. That's a mistake too, in my opinion. I think it's really important to have strong gating between dev and stage and prod. Okay, somebody said when dev is down, a whole department is twiddling their thumbs. Well, don't break the build. But if you don't have a little bit more liberal permissions in dev, what are you doing? You're going back to the security team and constantly asking for more and more and more in order to get your job done. So my own view is, you know, yeah, don't break the build in dev. If you do, you better fix it. I think we all kind of live that way, right? So try hard not to break the build. You might want, what we do a lot of times, we have our own private dev environments, and then there's the integration dev environment, right? So break your own, but don't break the integration environment in dev. But it is okay to be very liberal in dev with permissions, is my view as a security practitioner and developer on cloud. But lock it down in production.
We have one question that came just to the panelists from Dave. In many security families, such as HIPAA, they do not allow star policies nor use of root account. That said, there are legit use cases where elevated admins need full star. How do we create, in effect, full access high-level admin without using that, nor without trying to write out verbose policies listing each resource and trying to keep this up to date?
So that's an interesting question. The way I'm hearing that is, how do I get around the, well, actually, that's not quite true, right? I was going to say that, so wanting star and being told by a compliance regime, you're not allowed to do star, I was thinking, well, that's the same as just enumerating all the actions anyway, but it's not, because star will grant new actions that appear inside of, you know, whatever, read or write, whether you've added them to the policy or not. So they are actually somewhat different. It might be a trivial difference, but they are different. I mean, you can do that, right? Now I have to look at, we don't live under HIPAA. We support HIPAA for policies in Fugue, so we'll help you understand HIPAA, but I don't live in it day in, day out. I'm not exactly sure how it's worded in HIPAA. As somebody, Sam just pointed out, there is a built-in admin group that is just star in IAM that comes with the AWS managed policies, and you can't get rid of it, by the way. So no matter what, there are certain dangerous policies living in your account. The question is, are they associated with anything, right? And I can't, I mean, that has to be incorporated somehow into HIPAA. So, but I'll look into that. I don't know, like, I mean, the answer that occurs to me is, you know, have very long enumerated lists of services, but it could also be something like during a maintenance window or something like that. You know, in a lot of compliance regimes I've lived under, you have windows of relaxation for controls when dealing with certain situations. Okay. Plan is to use waivers. Yeah. So somebody said, I deal with HIPAA and our plan is to use waivers. Yeah, I mean, we're actually adding waivers to the Fugue product itself because we deal with all this stuff all the time for our customers. Yes. Okay, so just to respect everyone's time, we're a little over, but I went through the use cases quick because, as seemingly always, I thought we'd get through more than we got through. Use case number one, first one to tackle is RBAC for a basic AWS account and to basically understand how to set up properly users, groups, and I would also say roles and attachment to policies. I would add to that, look at the other policy types when you're dealing with things at a simple level in IAM. Look at things like for example, an S3 bucket should always, always, always have a bucket policy, not be reliant on IAM for security, in my opinion. So learn the stack of policies and do it when you're still small. Then you can move on to when you really start to grow, and whether you already are in an organization that's huge and distributed and dispersed, or if you're just learning this to begin with, I would still start by getting my head around the problem space in one account or a small number of accounts using RBAC. And then I'm a huge fan of the ABAC, the attribute-based access control for scoping those action and resource type policies by team. And then finally, third use case is writing policies that are going to be used in the production environment. Never, ever, ever put like list permissions for S3, never put IAM grants on stuff that's going to be running in the infrastructure. Like if you have an EC2 instance that can change IAM policies, it's game over, right? And also, if you're doing EC2, never have an EC2 instance running a policy that has the action, I think it's EC2 assume role, which allows it to change IAM roles. Again, that's almost game over. So I'm going to stop there.
You have time for one more?
Oh yeah, I mean, I'll go as long as people want to.
So here's one. Is it a good practice from a security standpoint to deny access to the AWS console and API from non-Office IP address ranges? If there are customers that need access to S3 buckets, how do we handle that?
I would view it as a pretty extreme decision to completely restrict console access. Now, if you want somebody going in through like a particular CIDR block or VPN to get console, that makes sense, right? That's okay. But you don't want like devs not being able to see console if that's what the, from non-Office IP address ranges. If there are, okay, I see. So console access is different than S3 read access, which is different than S3 list access. So the question is it a good practice to deny access to AWS console and API from non-Office IP address ranges? Okay, those are very different things. AWS console and API are very different things. If there are customers that need access to S3 buckets, how do we handle that? Okay, you can do, we did a whole one, and we're gonna do another one, part 2, but S3 is, we kind of started with the 2 most complex services in a way from a security perspective, IAM being by far the most complex, but S3 is too. There's cool stuff you can do with bucket policies on S3 where the end user does not need any kind of IAM grant. It can be IP CIDR block based. Personally, I would probably grant them access through like role arms, and I would get IAM in the mix, so it was not IP address block based, but you can do it that way too. There's tons of flexibility in the platform. So I can't tell you exactly the right way to do that, but I will tell you it is entirely possible for S3 and APIs to be configured in such a way that legitimate outside entities have access. There's actually stuff in IAM for doing that. And as well as the resource policies, and not be exposed to the general public. All right. Do we still have a crew? If we've still got a crew, we've got a pretty good crew. I'm going to do another background, and we're going to switch gears here. And we'll do a science fiction movie. If you're a regular attendee, a bunch of these are, somebody said Tron. Everyone guesses Tron first. It's not Tron. Galen got it. It's THX 1138. This is the Galen, that's just a panelist. So Sivia, you see Galen?
Sorry, I had to come off mute. Yes, I do see Galen. Galen, winner, chicken dinner.
It's George Lucas's first sci-fi movie. And it's kind of cool, but the motorcycles are sweet. That's back when they still had, look at that, a lot of style. Hank Hendricks asks, where did we have time to see all these games and movies? I've had 49 years to see all these games and movies, so I've had a little bit of time. Yeah, Galen says it's both fantastic and terrible all at once of THX 1138. I have to agree with that. Okay. I think we're going to wrap up there unless there are any final questions. I'm going to stop sharing, and I think we've got like a closing slide. Yeah, here we go. Drew, I'm going to turn it back over to you.
Oh, thanks, Josh. This was a lot of fun. I appreciate everybody joining us today. Don't see that closing slide, but want to make sure everybody's aware of the upcoming cloud security masterclasses. We're going to kind of keep doing these because it seems like people get a lot out of them and they're a lot of fun to do. So we'll keep on trucking.
Seeing it now, Drew?
I am. Thank you so much. Thursday, July 16th, we're going to be doing part 2 of building a highly secure Amazon S3 bucket. And you can go get caught up by viewing part 1 on demand. Also check out the conversation with Greg McCord from CalAmp. We'll get into a lot of cool subjects there, including some IoT security, which is pretty interesting. And we will be announcing possibly this week or next week a session that's really all about bringing your existing running cloud environment into compliance and doing so as quickly and painlessly as possible with the fewest business disruptions. And if you hate compliance and you're working on cloud, this is the session for you. It's not really intended for compliance professionals, but really kind of the cloud engineers that love it or hate it, really own the compliance of your cloud environment. And we think that this will help kind of remove a lot of the pain that goes along with, not only just getting things into compliance, but being able to prove it to all of the folks that require you to prove it to them day in and day out, management, auditors, etc. So I think we'll do our best to make compliance fun. And always check out Fugue. We have a free plan for Fugue for individual developers. You can find that at fugue.co/go. And it takes you about 10 to 15 minutes to get a full dynamic visual map of your cloud infrastructure environment and validate it against any number of existing compliance frameworks that are out there, including the Fugue Best Practices Framework, which is going to catch a bunch of nasty misconfiguration vulnerabilities that the compliance standards miss. So thanks again, everybody. Appreciate you joining us, and we will see you next time.
And I did want to let people know that we will be sending out a link for on demand. We've had that question a few times. Thank you all.